Just to make a quick recap, we were talking about the potential AI strategies that can be done, the Gen AI strategy, the regression strategy, and we decided to go through the classification strategy. So the classification strategy is using the triple barrier method, as we mentioned, and based on the category, we can predict if it's going to be 1, -1, or 0. We pick a model, we are using random forest for now, or we can pick a deep learning model, that's another option. But the idea, as I mentioned, was more to show like the pipeline, the overall pipeline of how to train, validate, and start putting those signals into channels. So then you can work on the model or you can work on another things. But the most interesting thing is how to do the full pipeline. The ideal solution that would be to have a machine learning server that this can be like the QuantLab task module that we have that can have access to candles, order book, and trades. And we're going to have different pipelines. The pipeline will be transforming the data from candles, order book, or trades to the scaled version of the data. So then we have a machine learning model that can produce a signal based on that. The main ideas behind this, at the end, we are going to end up having n pipelines that will produce n signals. And the signal, we have an ID, a market, a site, and a probability. We're going to send those signals through MQTT, that is a broker, and the different HBot instances are going to be listening to this signal to decide what to do. The next step that we showed that we need to do were making the scalar pipeline transform the data frame with indicators. Is this MQTT that is used in deploy? Yes, Emerald. The MQTT is a broker that will let us send the messages to the different bots. We have this standard scalar that we feed and transform the data, and then we have this value for that, right? And here in models, we have the pickle of the scalar and the model itself. So the idea is that if in this scalar, we can call it, instead of a scalar, pre-processing or something like that, and we can include all these transformations that we are doing to the raw data frame in that object, then we don't need to do something strange in the controller or in the signal generator. It's just like doing the same transformation. Finish the controller and test it in production. Add the notebook for backtesting. Add a task for automated training with Aptuna. Configure YAML for automated data collection in 1 second. Define if we require dedicated server for signals, or we're going to use the HBots and go define a solution. Machine learning plus automated trading. So this one, we're going to remove it because we already defined it. And we're going to dismiss this one for now. Finish the controller and test it in production. Well, the first thing that we need to do now that we're going to work on is create a task that, based on the logic that we did, is like, remember the pipeline that we were doing is we are downloading the candles. So this will be like, instead of downloading the candles, it's going to be streaming the candles. So once we download the candles or we stream the candles, we apply the transformation. The transformation is in indicators, scaling with the object that we use for to scale the data. And then the next part is to predict with the model that we are generating, right? So this will be the thing that we need to do. Now what we need to do is to do it like in real time. So in real time, we'll be doing all these steps, but with something that runs forever. So for that, I'm going to create a new file. For now, it's not going to be a task because it's going to be something that will run forever. So let's call it like prediction service. And this prediction service is going to be, let's call it like class prediction service def init. Let's put as an init the scalar path, model path, str. We're going to load these two things, and then we're going to get candles feed based on the config. So now we have the candles, async def prediction loop. Then move this and let's put candles ef, candles ef, candles ef. Prediction service, let me put here, and this will be candles ef. This is going to be everything candles ef. Here, here, here. Everything here is candles ef. Then the standard scalar we already loaded, so this will be self.scalar. This will be just transform. This is something important that we discussed the other day, that when we are doing predictions and we are using data or models that we were using in the past, if the model was trained with a certain scalar that uses certain distribution of data, we can't use a fit transform again, because that will be like very adjusted to the current dataset that is available. So we need to use it with the original model or the original scalar that we were doing. So in that case, we need to use this original scalar and just transform. Let's try up to this point. If everything works, we can do async def main, and we can put like USDT 1 second, prediction service, await prediction loop. So we can do if name equal main, async IO, run main. Let's see if this works. Let's put a breakpoint here and let's debug. Type error, connector, Binance, trading pair, BTC USDT, interval, this, max records, let's put 1000 records. Let's start again. With open file, file not found. Okay, that's expected because model we are here, so we can do root path file not found, users daemon code quantslab, model no is models, that's the problem. Let me redo the scalar now. For some reason I'm storing the scalar with format pickle instead of doublelib, but for now it doesn't work. The problem here was that, and this is pickle. Let me rename this to model. Okay, last intent. This is the proof that we are building things live, because we have a lot of errors. Self candles, market data brother missing config. Okay, now last time. Well, I can just use the candles factory, get candle and self.candles.start. Okay, last time. Get candle. Okay. Okay, now we are finally there. Candles are not ready yet. The problem here is that the candles, they have like an async loop, right? They have an async task that will stream the messages through WebSocket and then request the missing candles via REST. Python is not Python is single thread, so it doesn't have multiple threads to be doing this in parallel. So the way that we can achieve this parallelism, that is not really parallelism, is actually running tasks in the same loop but with awaits, like in an asynchronous way, is with actually async code. In this case, I will tell you why this is not working, but if someone wants to guess why it's not working right now, why the candles are not getting filled, you can guess why. If nobody knows, I will tell you the reason. But there is a problem with this current logic that will not let the candles get filled. Someone from the audience would like to guess? I want someone to guess, but nobody's guessing. I will help by putting a breakpoint here in candles. You are blocking the loop? No, it looks async. Yeah, it is async, but the thing is the following. Here, when we are like looping to get the candles, we are like connecting a WebSocket, subscribing to channels and so. Yeah, perfect Memento, you did it right. The thing is that here in this prediction loop, there is a while true without an await. So the only thing that releases this task to continue to another task can be an awaitable. As here we don't have any awaitable, we are not letting the process to continue. So if we want to really have the candles getting updated, we need to run await async IO sleep, and let's put, I don't know, 0.05 seconds. Okay, so this will let us release the task of prediction loop, and the candles are going to be able to get ready at some point in the near future. So if we run it again, at some point it should go here. We are here. Let me see what is solve.candles. Binance BTC USDT network not connected. Sorry, I put the await here. I should be here. Now we get up to this point. You see that before we didn't get up to this point. Now we are here because we have the async IO sleep to really understand that. Well, now we have another problem, a data frame object. Well, the good thing is that we reach up to the point where we are adding indicators to the candles. The bad thing is that we have an error, but the error is because we didn't import in the necessary library, that is import pandas TA as TA. Okay, now let's run it again and let's put a breakpoint. Okay, key error not found, close time. Okay, this is better because we were trying to drop these columns, but we don't have them because we were applying the three-variable method in the other notebook that we don't need it here. So let's run it again. This is a class on how to debug, actually. Remove close type. Another exception. Okay, this is also not in the data frame. Aracle says, if you ask to a WebSocket service, there are try exit options with no error numbers, better no just sleep. Yeah, but that's another thing, Aracle. The WebSocket connection is actually done like that. You only sleep if there is an error, and then you recreate the connection. The problem here is that as the other async task was running, all the program has to be async. And if the main loop is not releasing, the task is synchronous and it's not being released, it's impossible that another async task is able to take control of the loop and run. Now we have another problem, I think. Missing target. We need to add the target that is not appearing here because it was computed here. Let me add it here. Here, std span, and here the std span is 200. Let's do it again. Okay, So where? Seems like we are transforming the data, we didn't have more errors. So if we go here, we get that the candles DF is this. So seems like we are ready to predict, guys. Now the thing is that we have this scaled. If we just call, I think, self.model.predict candles DF. Okay, we got predictions, guys. It's everything long. What is the state of the market? The predictions were like 900 predictions divided by 60 seconds in 15 minutes. The last 15 minutes was predicting long. 15 minutes is like this amount. All this time was predicting long, the model. There is a very big opportunity with the model probably. But well, the thing is that we have the pipeline already. Now we have to improve the model. But we already have all the pipeline ready to start sending the predictions. So now we need to use the common lib to send a message through the broker. And then we need to create a Hummingbot instance that can stream from that specific channel from MQTT and start showing the predictions. So this is fun actually. Well, I think that in terms of time is almost like the same. Let's get out the predictions in case that you want to do an average later on, all that stuff. Well, we can do that. We can do the average of the and also we can do predict proba. This is more interesting than predict, because the thing here is that with predict, I don't know if you know how it works. So basically, when you call the predict method, what you get is a prediction for 1, -1, and from -1, 0, and 1. So the thing here is that it will get like the higher value of the predictions. So here 0 is like -1, like 0 is short, 1 is do nothing, and 2 is long. So in this case, what we can do to clean up the signal is saying everything is 1 unless that the prediction of the number 2, this column is greater than 0.5, or the prediction of this column is greater than 0.5. So that will reduce the signals a lot actually. But well, for now, let's keep with the predict. This is like the probability that is this category, or the probability that is this category, or this one. This is, I remember, short, do nothing, or long. So let's keep with this logic, with the original, that is like, or we can send the 3 predictions, I think. Yeah, let's send the 3 predictions and let's show in Hummingbot the 3 things. My question is, should we get the average of the last X periods? Well, let's do just send the last value, and then let's resolve in Hummingbot the message, how we are sending the messages. So here we can call predictions. Prediction is going to be self.model.predict proba -1. So if we call this, we just get the last value. Okay, perfect. And then we need to send it through the broker. So to do that, let me see how we are doing this in Hummingbot, because I totally forget how we are sending the things. Let me go here to understand how we're using the broker. So in B2 with controllers, here pub e-topic publisher, in this one here pub performance, use bot prefix Okay, we can do something simpler for now. That is just copy the remote interface to the core. Let's see if this works. Let's see if we have any importing issues. No. Okay, seems like we are all right. Oh, the Hummingbot application is the only thing that we don't have. Or we can just check how the eTopic publisher works. This one, MQTT gateway. Oh, we need the Hummingbot application here. I think that we need to rewrite a little bit of this. Or we can just do a much more simpler thing. I think that we can just ask the AI to do it. Let me open cursor here. So I would say to cursor, I have this pipeline almost ready, but now I need to send the predictions through MQTT. Docker, wait, check Docker. Oh, I will need to run the Docker. I will need to run PyCharm deploy new window Docker compose and dashboard again MQX 5. Cool. I'll tell cursor I have an instance of MQX running on Docker in my local machine, so please send the predictions in a topic called ML signals with the following format, and this will be, as we mentioned here, ID, this can be timestamp, trading pair. Okay, a lot of code. Well, in this case was actually good. It was not bad. Let me go up to the publish prediction. Let me put a breakpoint here. Nice. Seems like it worked. Can you create another file that listens to... Okay, I will ask to create another file, and if it works, it will be amazing. And now we need to go to Hummingbot and create a listener. So it created this new file here, research notebooks, MQTT listener. So let's run this. Oh, nice. Congratulations, guys. We are streaming the signals. So that's really cool. Well, now that we are here, we need to put it into a controller now. Open recent. Let me ask cursor to create a format status. Add a listener to this controller. Receive. And I will put here. Close this. And I will put here. This is an example of 82 the signal. Okay. And then I will ask also to place executors, filtering the executors based on the signal only. So that will be like the last thing. And then we can just run and see if we are doing this properly. Then I think that with this we're going to end. The next session starts like creating the infrastructure to scale the models, all that stuff. Create actions, this one, get levels to execute. Can you also filter the list of probabilities in get levels to execute? Okay, I think that with this we're going to be really close. Well, now it's time to debug. So this is okay. The config didn't change, I think, from the one that I have. PMM ML, let's call it ML. Controllers, change this name. PMM ML, PMM ML. Well, now let's run it to see if we have errors. Status live. Seems like we are not receiving the ML signals. Stop. Because I'm still running the PMM controller in the script launcher. So here in scripts, I need to change this to PMM ML.yaml. Let me start again. It seems like we are not receiving the message here. We are trading, but without the filters. It's like we are doing some trades here. We are not actually filtering or receiving the signals. Maybe the prediction service was stopped, and that's why I wasn't receiving the signals. To be honest, I found this complex. Yeah, well, just to make a quick explanation of that, this MQTT, just to understand how it works, is like a message protocol that we are going to be sending messages through it, and the different HBots are going to be able to access to it. So the way that MQTT works is like we have topics and we have events. Probably is worth to use events rather than topics, because I think that the difference between the topics and the events is that when you are sending a message through a topic, it's like, let's say that we have this topic, and this topic, right? So this topic thing is like, let's say topic A, B, and C. So an event is like we are sending events, and we are going to have here producers, and we are going to have consumers. Consumer 1, consumer 2, and consumer 3. So let's say that this producer will produce messages to here, and to here. And let's say that it only produces, let's simplify to just one channel for this analysis, because this topic can be machine learning signals, can be another topic of position risks or whatever. It's like each topic should receive messages from the same type, possibly, right? So here in this topic we are going to have a queue of messages that are going to be arriving to, it's easier if I just use one. So each of these will be a message, right? So these messages that we are receiving here are going to be consumed by these consumers. So imagine that you want to make a trading system that you publish orders and you have services in different IPs. So you want to send the message as soon as possible. You're going to be using something like this, because these messages are going to be consumed by these consumers. So the consumer will say, is there any message on the queue? If there is a message, the message will fly and go to the consumer, and the consumer will process it. So It's simply like a way to communicate messages through different services. In Hummingbot, you have something really similar that is like the async queues. It's not similar, but imagine, just to make a comparison, it's not the same. But the async queues, you put a message in a queue, and then you have another process that is reading from that queue. This will be something really similar. This will be the machine learning process that will be producing the signals and putting those signals on a queue, and then we are going to have another bot that will be consuming from that queue and getting the information from there. So that's basically how it works. The problem that we have here is that we are not receiving the messages from the Hummingbot side. We are producing the messages, yes, because here we are seeing that we are sending the predictions. But the main problem is that we are not actually receiving the messages here. Okay. The problem of this design is that the topics that we were using is hbot / this ID, that is the ID of the conf client probably, yeah. See, that is the same ID here. And then ML signals. So just to show you that that is potentially the problem. Let me restart this thing. Let me release this. Now we are producing, and now we are receiving the signals. So yeah, we did it. Status live. Just understand what it's saying here. The status live. Probabilities 40% for class 2. We are placing orders or not? Yeah, we still place orders. So in this case, it's like working. We need to really get into the models, because as you saw, the model is always saying 0.4 long or nothing. So there is probably a bias into the model. So we need to set up a good pipeline. This model was trained last week with 3 days of data. We need to work a little bit more on the modeling and the services that are like collecting the data in real time, training the models, processing, dumping new pickles for the scalars, and new pickles for the models, and another server that is producing the signals and stuff. So that requires more work, but well, this is why we are doing this. We are doing it live all together. Well, I hope that we can reach up to the point that someone else can continue working on this on the live stream channel on Discord, helping me doing this, or providing more solutions to the stack. So well, the good thing for now, coming back to what we were saying, just for the ones that just showing, what we did was we created this prediction service that is sending the messages through MQTT. We work on this AI strategy that for now is more like how to put all the building blocks together. So we started with notebooks, like how to download the data of Bitcoin in 1 second, all the stuff. Then how we did the feature engineering. We add a few indicators. We removed the columns that we don't need. We scale the data, and then we dump the scalar so we can use it later on with the same like distribution of data in new data. And then the last notebook is this modeling notebook that we were loading the pre-processed data, and then we were using the scale. Well, it's already scaled the data, but we're doing a train test split. We were creating a model and fit it to the data, and then dumping the instance of the model. So at this point we have market data, a scalar that will let us normalize our data, and a model that will let us generate predictions over the data. So with those files, we're creating this prediction service for this Bitcoinator. We set up an MQTT. MQTT is the broker, as you know, is this architecture that we are seeing here. This is one of the pipelines that we were like saying here. We set up the prediction service that basically loads the candles that we were using. The candles receives via WebSocket the new candles every second, and with that we were applying the transformations. With those transformations, we were using the scalar that we loaded from the file system and the model that we loaded from the file system, and we are publishing the last prediction through MQTT. So as you can see here, publish prediction, the ID of the prediction, the trading pair that we are predicting, and the probabilities of short, probability of do nothing, and the probability of long. And then what we did was we created a Hummingbot script, a Hummingbot controller that basically is one of the controllers that I have been working that does market making. And as you can see, Memento, this is for you that we were discussing today about the trading volume. We traded 1300 in 8 minutes, so that's the ratio that we were talking about. This is with a config of total exposed. Total exposed now is less, but the total amount will be 1.7k. In real orders, we are sending like orders of $5, $12, so it's very small the amount of orders that we are doing. So well, what we did was we created this controller, or we adapted this controller that basically streams the predictions from the MQTT service that we just talked about. So there is one service that will be like this one, the ML server, predicting and generating signals for different markets, and then we have different HBot instances that are streaming those signals and saying, okay, the probability of class 0 that is short is 27%, the probability of class 1 is 31%, the probability of class 2 is 41%. So based on these probabilities, we'll take decisions. For now, we just filtered the opposite trades. So we said if the probability is greater than 40% of long, we are not going to place shorts. So that is basically how it's working right now. But obviously that this can be further improved based on what you think that the strategy has to do. For now, it's just the pipeline. It's how to connect the prediction service with Hummingbot. Next session, we should continue working on understanding what's the right way to standardize a little bit the process of training the models, like downloading the data and setting up certain times where we are going to trigger the training process. Rafael says, how this is better than doing everything as controller in Node B2 way? Well, Rafael, that's a very good question. We discussed that actually in the last meeting. I asked like, what do you think? We require a dedicated service for signals, or we can use HBot for prediction. This is what we were saying. And actually it's very similar. It's like we are doing the B2 way. It's like this is B2, but the main difference is that Hummingbot can be very lightweight. It's like you don't need too much for Hummingbot. You just need one CPU and 1 GB of RAM, and Hummingbot will work. So the thing is that the prediction might require some computational resources, and you will probably have this ML server somewhere else because it has, I don't know, GPUs, or it has better specs, your computer, to generate those signals. So you don't want to delegate that to each Hummingbot instance to make the predictions. So, and also it's like, let's say that you have different instances trading Bitcoin, probably you want to centralize all the signals that you have everywhere. So this is very good because lets you scale, and probably instead of having just one model for Bitcoin, now we can create 10 models that are predicting Bitcoin, and in Hummingbot we just make the average of all the signals. So decoupling those services is going to be really good in a long run. Plus, right now I adapted a market making controller. So as you can see, is trading more like a market maker. But the thing is that what we can do in the future is to create like a directional trading based class. We can create the control directional trading controller. We can create a machine learning controller base or whatever. With that controller, we are going to be able to to use just this server to start spawning signals. You don't need to code anything in Hummingbot. You just need to code the machine learning signals. So I think that has some benefits, mostly for the people that doesn't know how to code that much Hummingbot or interactions with exchanges. You can just provide signals. So, well, that's all for today. I hope that you like it. Creating a task that streams candles and sends. This is done. Finish the control and test it in production. Also is done. Adding a notebook for backtesting. This is not ready, but I will prioritize these two tasks for the next week. And then the final solution will be a more robust version of what we did. Remember that we built all these in 3 live streams, where the first part of the sessions we were always talking shit about different things. So don't expect this to be something really professional for now. But we did a lot in 4 hours almost of work live. Guys, we built a machine learning service that sends predictions to Hummingbot. So congratulations for us. We did it. Well, anything else before we... I'm working on the candles currently. Maybe I should look into having MQTT plug in. I don't know how you can relate like candles with MQTT, Memento. I think that we should be using the MQTT more like to send messages through different services like this, or to send like P&L reports from the bots. Actually, if you review the backend API, the backend API has a listener of the P&L reported from the controllers, well, from the B2 with controllers. That is why we have the dashboard with the metrics and all that stuff, because the backend API is like streaming that stuff. So I think that I will keep the MQTT for that. For all of you guys that are in the call, Memento is working on a big refactor on the environment. That is like the most important thing for me for now, because we are trying to update the dependencies. Rafael says P&L. Let's see the P&L. We are 20 cents down. We traded 2.4K. That's not bad. From realized P&L, we made 18 cents. That's good. And we are holding $273 with a break-even price of 83.8. So if the price goes up here, we are making money from the unrealized. Yeah, MQTT fails the test. Yes, but I thought that you were mentioning, Memento, that you want to merge the candles with the MQTT. I thought that from the message. Maybe I misunderstood. But yeah, if it's using the candles at the same time with MQTT, I would say no. If it's looking at MQTT, I would say yes. If you check the new B2 features, I added the ability of positions held, that now the executors can have this keep position equal to true. So if you put stop executor, keep position true, the position will be accumulated here in this bag. So instead of taking loss, we are like holding the unrealized in another bag. So as you can see now, we are like, I don't know, 20 cents above. So this opens up the possibility to keep a position over time, because right now it's like $285. I would probably want to have that amount of Bitcoin in my portfolio, even if it's holding some loss. I would like to hold it probably, but maybe at some point, as it's market making, I don't know, the price goes up to 84300, and I would like to start sending more set executors to try to do the markouts. But if I keep the position, it's like reducing the other position and making profits from it. So, well, there is a lot that I have been working on, mostly to give more flexibility to the framework. Right now it's like very complex. I know I will be simplifying it at some point, but everything that I do it because I use it by myself. So I try to think what's the best way to manage. Is funding our bot in Python still functional? We are revamping that strategy. We are combining statistical arbitrage with funding rate. That's something really cool. For the funding rate, it should be live still. As I mentioned in the video, the strategy needs some tweaks, because if you check the transaction costs for doing the trades, you will see that there is a calculation. You need like 1 or 2 days until the funding rate covers the transaction cost of entering the 2 trades. You will need to build the position progressively to really make it something that can make sense. So in case that you want to build a strategy, what I would recommend will be quoting the 2 exchanges and trying to get the fills from the two sides. So it will be more complex than the current strategy as is, but I think that is something totally doable. In that case, what you will do is like you go, let's say the best thing to do is to go to Hyperliquid funding comparison. Well, here you have this type of information. Let's say that we would like to see the best arbitrage opportunities in bear chain. So you need to go long in Hyperliquid and short in Binance, and this will give you this percentage. This is every 8 hours. So see that in a daily basis is like 0.13%. It's quite a lot. So in this case, it actually can be at market probably. But see that the difference between doing it at market and doing it with limit orders is quite high. So I think that the best way to do this is building the position progressively through the 2 exchanges. And progressively, I mean, like, let's say that you want to totally invest, is like the total arbitrage that you want to capture in Vera is $100, right? So you can send an order of put up a limit buy and a limit buy in Hyperliquid and a limit sell in Binance of $10. If the 2 of them are getting filled, it's like you already get a kind of arbitrage between the 2 positions that you are getting, plus you are reducing the cost of the trade, because instead of paying 0.03%, you are paying like 0.01, so it's like 3 times less of fees, and you are not exposing everything. So yeah, that's my recommendation in case that you want to do funding rate arbitrage. In case that someone is really interested on this, or if you guys are really interested on this, we can continue the series of live streams doing that, because right now we are building the machine learning strategy. So I would like to finish that before moving on to another thing. Yeah, Emerald, is interesting what you are saying, but the thing about the funding rate arbitrage is that you balance the position by going long and short in the 2 exchanges at the same time. It's like if the price goes up or the price goes down, you don't care, because you are like long and short at the same time, so you are hedged. That's something that is important to understand. And what you're saying can be in a special case. Let's say that you quote from the 2 sides. You quote in Vera chain. Let's go to here, for example. In Vera chain, let's go here, futures. We have to play like a buy order here and a sell order here, right? For doing the arbitrage, because here the funding is minus 0.03. Here the funding is minus 0.087 short. So here is long Binance, short Hyperliquid, because this funding is bigger here, I think. But well, it doesn't matter this example. Let's say that you place the two limit orders. There is a chance that the price goes to one direction automatically. So in that case, what you can do is to use one of the exchanges that has the higher cost of transactions. That should be Binance, because I think that the fees here in Binance are, yeah, the taker is 0.05%, and Hyperliquid is 0.03. So the taker fees in Hyperliquid are lower, but you don't need to only take into account the fees. You need to take into account the fees plus the price, because it's like probably the discrepancy of price is already higher than the fees that you are paying. So maybe it's worth even to trade at marketing one exchange another. But well, so what you are going to do is to place the limit orders, and if suddenly one of them gets filled and you have a threshold of time for the other order to get filled, if it doesn't get filled, you can hedge it at market. So that probably the potential change that you have to also do in the strategy. Yeah, the price is really different. Can be also related to this funding, because someone, like, it's free money, this arbitrage. So if it's free money, someone should be like trying to take this into account. So yeah, another option that you can do is to, besides doing this, you can take a little bit more risk, because let's say that you want to incorporate kind of directional trading into this. It's like, imagine that now, I don't know, our model is saying long, and we get paid more to long. You can start taking long in the exchange that pays you, and when the price goes up, you can start taking shorts in the opposites, all that stuff. Rexy says, is there a video you can direct us to create bot on XRPL using DEXs? Rexy, that's a really good question, and soon we are going to do a few announcements, because we are collaborating with XRPL. If you put here XRPL, yeah, here there is an explanation of how to use it, how to connect, and everything. Probably we can also add a video in case that you have problems with something. Rich Monkey says, hi there, I want to connect to DEXs through dashboard. Can you please give a rough idea of how to do it? I want to do arbitrage. So here in Hummingbot deploy, you will see that you have this Docker compose, that YAML. In case that you would like to add the gateway, you should be adding the gateway as another service, or you can run the gateway from source in the same machine that you are running it, and the gateway will be available for the bots that you are deploying. The question now is how you can connect the gateway to the actual bots. It's like, imagine that the gateway is a service, it's a server that is running, waiting for requests to trade in the blockchain or to get the data from the blockchain. So you have Hummingbot instances that are going to be talking with the gateway to interact with the blockchain. So if you have the gateway running in the same server, you need to tell how you're going to be accessing that information. So here inside bots, credentials, the master account, this folder is the one that when you are spawning a new bot, it gets like cloned. Like when you create another account, this is the one that gets cloned. And this is the one that you are usually going to use. So if you have a fresh Hummingbot instance, this inside the conf folder, you're going to find the same things. So here in connectors is where you're going to find the credentials and everything. What you will need to do is to replicate what you have here with your local account, and that will work. And the conf client has also another configuration from the gateway that you can also use from there. There is no straightforward method right now. We're going to add it, but right now Mike is really like working on improving the gateway. As it's not stable right now, I will not want to spend too much time doing something that probably I need to redo later on. But this is like a general information of how you want to do it. It's not going to be straightforward, I will tell you right now. Arakel says there are bots from the exchanges to avoid the arbitrage. Also services as Chainlink has channel to spread these balances. What you can do is to, instead of using just one price to market make around one price, what you can do is to create an index price based on multiple exchanges. The way that you can do that is to get the order books of the exchanges that you want to trade on, and based on the order book of those exchanges, construct like an average order book and get the VWAP price from there and use that price to avoid the arbitrage. But I would say that that's a lot of work. Well, not so, that is not so difficult. It's to create like an oracle price, but it's not as easy as I will prevent to have arbitrage, because maybe the arbitrage is 0.01% or 0.05%. So maybe it's too low to do all that. And maybe you're taking into account another thing. The dashboard is really lagged via Docker. Any faster solution? I didn't use the dashboard for a long time. I don't remember the dashboard being really lagged. I think that the next move is moving to Telegram. Well, guys, see you. Have a great weekend. Okay, bye bye.